Good afternoon, ladies and gentlemen, and welcome to the SAIEE KwaZulu-Natal Centre webinar on innovation in protecting railway assets. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. And by default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV. You will find the registration link in the chat box. Please register, it's free. And the recording of this webinar will be listed under the KZN Centre playlist. A certificate of attendance will be issued a few days after this webinar. I'd like to introduce you now to our host tonight. My apologies. Mr. Shepherd Nkosi, who is a past chairman of the KwaZulu-Natal Centre, and he is a highly accomplished executive in the built environment. His passions lie in energy, sustainability, and business development. He has actively contributed to various professional organizations and institutions throughout his career. He serves as the past chairperson and committee member of the SAIEE KZN Centre, holds the position of vice president on the Durban University of Technology Advisory Board, and is also an advisory panel member of the University of KwaZulu-Natal. He is professionally registered with EXA. Over to you, Shepherd.
Thank you. Thank you, Minx, and good afternoon. It's actually almost evening. Good evening to everyone. Thank you for connecting, and I'm sure we're looking forward to hearing more from our main speaker this evening, Nathan Dean Brown, who is an ICT specialist and a consultant. So I'm sure you've noted the theme, can we be innovative when it comes to rail protection? That will be the main theme that Nathan will be covering with us this evening. So Nathan is an ICT consultant. He started his career in the ICT sector as the software developer in the late 1980s. He also became a network administrator and a system engineer as the network and Microsoft in the 1980s, and also started his own ICT consulting business in 1981. So he has also served a number of clients in the ICT sector, and within his list of clients, he has covered the public sector, national and provincial government, and also private, both local and international. I'm sure you're keen to hear more from Nathan, and I would like to warmly welcome you, Nathan, and thank you in advance for preparing this presentation for us. And over to you, Nathan.
Thank you, Shepherd. Thank you, Minx. Just confirm if you can hear me, please.
Yes, we can.
Yes.
Okay, thank you. Good afternoon, everyone. So I'm going to jump straight in. I mean, we can have some questions later, so if there's any time, so I'm going to jump straight in. So a couple of logos on the screen. So Sinkubele is the logo on your top left is a company security guarding solutions organization, guarding, monitoring of, and having staffing as one of their primary assets to protect assets of different clients. So Sinkubele provide the bodies to do the guarding. The Tava is a company that runs our control room, so 24/7 control room monitoring and always on IT. My organization, we are a implementer. We design solutions and we take it to market for our clients. So what I'm going to go through is how are we using technology to protect rail assets. Traditionally, the technology we've used, and we're all familiar with them, it's electronic alarms, sirens, CCTV, armed guards, and response. But as we all know in South Africa, this poses quite a few challenges. Added to those challenges are the following, which we experience with the rail network. It's remote locations, We've got vandalized perimeters, which is deliberate, so they break the immediate fencing to protect the assets, so that is vandalized. Quite often we've got assets alongside public stations or informal settlements, and once the fence has gone, very difficult to ensure the assets remain protected. Infrastructure, power and telecoms, with the power outages. Let me not tempt fate. We've not had the load shedding in the Western Cape for a while. I think it's not the same across the country, but it's been far more stable. But with Eskom outages, all the traditional systems that we've typically used fall away or become more compromised. So we are left trying to find, and by we, I suppose, all South Africans who've got an interest, who have assets or investments in the country, by looking at the rail assets, we need to find a fit-for-purpose solution. We've embarked on the following. So we've got resilient technology that we use. For power, we've got power from Eskom via rail the substations that we protect. We've got a solar panel on the roof that we install, and we've got lithium-ion batteries within the site. So we typically have, as I say, the backup alternatives. We monitor in the technology stack that we've deployed. We've got a sensor or a relay. So as soon as the Eskom power goes off, it notifies our control room, so we know we are running on solar and or battery. And we've got time to proactively get support teams into the field to go check on those substations. From a telecoms point of view, we've got a primary link. Now, currently the solution we have is using the various cellular networks. So it's Vodacom, MTN, Telkom, and Cell C. So we've got 3 different SIM cards at the substations. We are still working to have an ideal where we've got fiber from the client as our primary, but for now we've got 3 different connectivity options to each of these substations. Then we've implemented live monitoring. So we've got targeted guarding, we've got managed access to substations. There's a process which we've put in place. So I suppose your standard operational procedures. We've got control rooms. We've secured the networks. We are linking all this information via crime intelligence. I'll speak to the crime intelligence and AI shortly or towards the end of the presentation. Using Internet of Things, no matter what we put in to protect the railway or any assets in South Africa, the criminals are always trying to circumvent all of this. So with using additional technology, Internet of Things, we hope to reduce the attack surface or the area where they actually hit these assets. So we just go on to the next slide just to give everyone a sense of the scale of the operation or the project we have. We are almost complete with this phase now in the Western Cape. So the rail network runs from Cape Town across to Beaufort West. It's a 478-kilometer network. So that is all the icons listed with a camera and with a little hammer there. Those are all the substations which are currently being protected. And just to have a sense of the challenge. Between Cape Town and Paarl, there's a Huguenot substation that's about 50 kilometers from Cape Town. Worcester is 70-odd kilometers, so it's impossible to have technology at each and every step of each and every point of interest, point of valuable asset across the network. So I'm just going to drill down to give you a sense of the scale of it. Within the Western Cape, close to Worcester, is a Gouda substation. And if I drill down to it, this is what the substation looks like. You've got a railway network or a rail line running across them. There's no fence on the rail network, but the substations provide power to the rail network. So just to give you a visual display of the environment that we are looking after. Very remote, so it's on the outskirts of the small little town, little dorpie in Cape Town. dirt roads right around, so no infrastructure or built-up environment around us. So typically all substations that we've done on this project are fairly remote. I'm just going to talk briefly on the next slide to see what the security measures we've implemented at the substations. So we've standardized on the Hikvision IP CCTV cameras. It's got a network video recorder and a primary LTE high gain router. We've got at the same location, we've got a Hikvision and IP-based alarm system with a secondary LTE connection in the JustWorks. So JustWorks is a service provider that provides multiple connections to, as I mentioned before, Vodacom, MTN, Cell C, and Telkom, and it jumps between the various networks, all from one device, from one SIM card. And then we've also got the traditional radio link, very difficult to knock out the entire radio network, which covers the country. So multiple ways to communicate with the equipment on site, which is the aim of all these different the routers that we have in place. Then we've got a VPN router. As I mentioned earlier, Syncobelly is the security company doing the guarding as the partner. And we've got control rooms so the VPN virtual private network just secures the networks from all our substations and all the control rooms. So no one else can see the traffic and can intercept the feeds, etc. So it's a secure network. I mentioned briefly, we've got solar panels with inverter for backup power, and we've got a remote power IoT device that tells us as soon as that power is disrupted on site. We've got 24/7 remote monitoring. So the control room, when any engineer, technician needs to visit a substation, so I suppose this is part of your standard operating procedure. So I suppose with many operations within business, that all comes down to people, technology, and process. Before a member of staff needs to visit a substation, they call the control room. We can actually see them on the display live, and the remote or the alarms are disabled remotely. They can then go into the place and do whatever maintenance they need to. We arm the alarms and the systems when they leave. We've got arm response 24/7. We've got remote audio capability via a horn speaker and a PA system as well on that site. So you can actually liaise talk to any would-be person vandalizing the property. So these are the measures that we have at the substation. I'm just going to give a couple of screenshots as to what the technology is, and this is by no means any different to what we have in our homes and offices and our businesses. So it's a network device cabinet. You've got some networking equipment in the switches. We've got the NVR. From the clip, you can see inside all the substations, we have a smoke detector right on top. We have a camera viewing and recording any access to this critical equipment. Typically, we find if there's a break-in, they try and disable the very thing that's protecting it. So the CCTV network is the first one they try and break. So we've got footage which is stored on the NVR. It is immediately also sent via the network to a recording device, a HIC central server at another location. So even if they had to take all of this, the footage, if there's a trigger, it's sent out immediately. I've just got another couple of slides on the actual substations. So we've got solar panels mounted in various formats to get the most use of the sun. You can see on the end, there's our cameras. As you can see in the background of this particular picture, very rural. When we get to a site, one of the first things we need to do is to try and see where is the nearest cell phone tower. And getting onto the top of the structure, the team needs to position antenna, high gain antenna, to see where is the best location to mount equipment at the substations. Just a couple of slides or pics here. That is the horn speaker. It's a extremely loud device. It's an IP device controlled from the control room. So the operators can speak directly to anybody who's any unauthorized persons on the premises at the location. This little picture in the middle, there's our solar inverter. There's a lithium-ion battery. This little device, IoT device, it's a wireless device. If the power goes off, it connects to the Wi-Fi network, sends a signal to the controller to say the power's gone off. We have an external sounder, so if the alarm trips, we've gone with this one's got a red light on it. We've changed most of them to the blue light. Just seems to, it's just a deterrent to have anybody on the premises know that they've tripped the alarm, and there's a audio clue or cue at the substation that you've compromised the security. On this particular one, there's another camera. These are the substation equipment. It's on the left-hand side. This is in the high voltage yard. Typically, those are from the transformer. The ones we would protect are the 11 kV transformers. The other lines run, I think, 60,000 volts. This is running at 11,000 volts. So they actually break they damage the transformer. They break and they knock the transformer. The oil leaks out, 10,000 liters of oil. It overheats, and then once the substation goes off, they try and steal the bus bars and all the copper. So this is exactly the equipment that needs to be protected. We've got sensors at various locations around the high value assets. As I said, the transformer, bus bars, all the operational equipment on site. On the sensor on the left, the top section is actually a camera. So if any zone is stripped, we've actually got video feed and footage of these cameras. The middle section is just a case of we've got structured cabling. Everything is monitored. Everything is labeled. Everything is documented. So from the control room, they've got not only the layout of all the cameras, they've got a floor plan. They've got the rotation, if you want, of where the cameras are on the site. They've got a Google Earth view of the substation. So when they're sending armed response to the site, they know exactly which direction you need to be looking, where the perpetration is, because as I said, it's completely remote. There are no street lights anywhere near these locations we have installed. The other ones, camera, each door as you get into the substation's got a dome camera. It's got a passive. So we've got multiple solutions. The camera picks up any movement once this thing is armed. We've got line crossings inside and outside of the substation. So 30 meters around the substation is protected by the camera itself. Inside, we've got the passives. These are all pick up human movement and detection, as does the little passive inside, running on two separate systems. So even if you hit the CCTV network, the alarm system is all wirelessly operated. And all of these little devices actually has a camera, that's a passive, with a camera, and I'll show you later on pictures of the footage from that. There's the high gain antenna on top of the substation. We use Google Earth to try and get the orientation right, all different tools. And I think here we've got our alarm system. We've got an antenna on the outside, everything about getting the best signal out. If you don't have a signal, if the towers go down, we can't depend on the one tower. So we actually hit 2 or 3 towers at the minimum. Just another one of the antennas. So we've got multiple devices depending on how far we are and what the strength of the cell phone signal is. So that one is a high gain antenna. This is a different Huawei device that we've used. Inside, all our devices are in waterproof covers. We've got some IoT device, and that's a radio signal that's outside, inside the Allbro box mounted against the substation. This is footage from a device, the camera within one of the substations. It's a bit grainy on here, but from a control room, they've got live high definition footage of exactly what's happening on the inside. We've actually used the camera. We've had an incident where there was a fire that had started because of the smoke detectors inside the substation, triggered an alarm. The control room was able to get video footage late at night. They could see there was smoke billowing out, sent a response team out for emergency intervention, and they managed to put out the fire before any further damage could take place at the substation. So live footage into the substation. Just another view of the transformer, sensors on either side, so complete perimeter protection. You cannot get near to this thing. In this particular substation, we do have a fence. Most of them have been vandalized, and Transnet are busy repairing all of this. By way of the control room measures, let me just go through what we've done there. We've got a Hikvision HIC central server. This allows for live monitoring of the substations. So as mentioned before, so the HIC central server pulls in all incidents, triggers, and events. So we've got a CCTV network that can pick up a trigger. You cross a line, a vehicle or a human. So we ignore on the CCTV network any just normal movement. Trees blowing in the wind, a little dusty walking across the railway track. Those won't trigger it. It's actually looking for vehicles and humans. That CCTV network then triggers it. It sends the footage directly to the central server, which is monitoring it, and it triggers it on the operators for them to act on that incident. We've got streaming server capability. So we've got multiple control rooms currently. There are 3 different control rooms, 2 in Johannesburg, well, 1 in Johannesburg, 1 in Pretoria, and 1 is in Bellville, which is being commissioned as we speak. We've got primary fiber router in the control rooms. Typically, it's 500 meg to a 1 gig Metro Ethernet link, plus backup connections via the VPN routers, which connects to the substation network. Typically, it's 8 operator pieces for this particular client at all 3 control rooms. 16 screen video wall, so it's got live and playback monitoring. We are able to escalate to the field response via the normal standard operating procedures. There's a tech team for supporting and to disarm and arm before you've got personnel who need to visit a substation. And just to give you some view as to what one of this is the control room in the Cape Town office, which is being commissioned as we speak. So full on view. Oops, sorry, let me go back there. I'm trying to zoom in a bit. Just give me 1 second. I think it's that one. So high definition graphic capability from an operator and supervisors who can manage absolutely all the substations that we have. Here's goes to. This is just some boring slide in terms of what is the technology we need to make sure it's a secure network. So it's security network protocols, policies, and considerations. I'm going to rush through them. So it's user authentication to make sure everybody who is accessing the network is a trusted source and has permission to be there. So multi-factor authentication is in place. There's role-based access control, as I mentioned, the VPN. IP whitelisting, once we've added a device to the network, only those devices are visible on the network. So even if somebody were to try and hack the system, it's only the IP addresses that we've configured that will work on the system. There's encryption, logs are audited and monitored, no user can delete anything. So being in the security field, one of the first things we have to do is to make sure all the users on the network that we are providing and protecting, everybody is authenticated. So we take great care to make sure we do not share information via very wide groups. So we do not want to be sending, for instance, a message, we've got a link down, a fiber network is down in certain area, and therefore we've got no visibility. So everything is treated with the utmost confidentiality and security protocols. So that's just a consideration before we put anything out on this network, which is enclosed and is trusted. So there are multiple layers of protection, even in the design. Audit logs, this is for making sure that we keep it's a watchdog over all the operations. None of the operators can delete any footage. So it's just to make sure, I suppose it's self-regulating, self-policing. So we do not end up on the wrong side, or any of our users or staff members. Regular software updates just from a vulnerability of all the equipment that we use and systems we use. Just a last note on protocols which are used. So if a port is open on the firewalls, everything is a one-to-one. Everything is denied except traffic that we allow, and all of those are using HTTPS and the rest of those protocols. I'm not going to share if I don't know the audience, if it's too technical. So secure ports, only known equipment, only known people on the network. Just by way of getting to how have we fared in the field? These are just a couple of slides from the live feeds across the country. This is in Gilbeck at one of the substations, and as you can see, it's fairly accurate, and you can zoom in. This particular one, I'm going to try and zoom in on. As you can see, here is an individual on our screen. This side, without running it directly from the Central server, it looks grainy, but I'll try and get you another one. They have enough footage on, or enough definition on the camera. For instance, on this particular camera, there's, I think this one is in a substation called Buerta. It's on a farm. Most of the substations border private property. We've got access to this particular farm. The operator could see in that vehicle driving past that there are two individuals in the car wearing high visibility vests. So don't be fooled by the grainy look of my slides. The operator could see exactly who was in that vehicle, and it happens to be the armed response doing a regulatory patrol at Buerta. If I go back to some other views, when you see the green blocks on the screen, that's basically picking up movement. So either a wire is moving, a tree is moving, so the operators can see that there is something moving. The cameras won't create a false positive or false alarm. It's only set up to pick up, only triggers an alert if it picks up vehicles and humans. So if I just go back, the camera would have picked up that vehicle, and hence the operator gets notified immediately. In your control room, this screen will pop up on an operator's viewing monitor, and he can immediately zoom in and see what has happened on that particular scene, as is with this person. There's another vehicle driving past the substation. Because we've got it set up to pick up vehicles, it immediately triggers an alert, and the operator needs to intervene to close this incident. That is the vehicle, one of the vehicles for the armed response identified. As I said, this I think is also on Buerta. This is on the private farm, and the substation has no fence around it. This is our teams out in the field doing the installations. I see that's at Lanesburg. And as you can see, a very sad case that the fence is partly up on the left. That's the high voltage yard, and a big portion of it is damaged, or it's actually been removed already. Unfortunately, I'm going to try and play this again, Remings. So this is a live footage of somebody or two individuals who have gotten to a site. They tripped the alarm. The camera that's at Bavian immediately picked up that there's human presence at the substation. Somehow we couldn't get the sound working, so I'm going to play the sound. And so what was actually happening there? The operator, having been alerted by the camera, so no intervention. It went straight, it logged a ticket, and it raised this straight into the control room as an alert. It shows you exactly which camera it is, and it says on the left-hand side, you can see it's Western Cape Bavian. It's on the railway line side. There's more descriptions there, and they know immediately which camera it is. she's basically told those two individuals to please move out of a restricted area. They've got no authorized access. And if I go to the next one, that is the railway line. There's the incident that was called up. She's talking to them. I don't think you guys can hear it for some reason, but I'll just play it. And what you've got there is, because they are monitored, this is the substation where they would frequently damage the perimeter and try and get into the substation. Now you've got the capability to identify people as they get there. You are responding to them live. And even though we don't have armed response there yet, they're actually moving off. And if I go to the next slide, those are the two individuals leaving. You can now, they can report that to your armed response unit, the team that's in the field. Red pants, check, red check top, and you can give the description. So they have the ability from the operators to zoom in and take a snapshot and send it to people. This you can't call it trespassing because the fence is gone. So they're just walking in an area which is not, they shouldn't be there. So the operators just asked them to please move along. So Minx, I think that is it from our side. And I'm quite open to assist with some questions that you guys may have.
Thank you so much, Nathan, for the well-detailed presentation, and I'm sure there's few questions from the audience. I don't see any questions for now, and then maybe if there's any questions that you would like to share, we invite you all to please share your questions via our chat box, and then we can go through those questions. We have touched, Nathan, maybe on the IoT AI, maybe some capabilities on the AI. I think it's quite interesting to note that almost everything nowadays is AI. And my other question I have for you, maybe while we're waiting for the audience, your platform with regards to your online platform to control, you've touched on the control rooms that you have. So how easy is your system to link with any platform that exists? I know security cannot mix with any other solution, but you have a building management system, you have other platforms that exist. How easy it is for this system to interact with any platform, obviously with proper control for the security side of it. And my other third question is, will this technology be applicable also for other solutions? I know we're talking about rail this evening, but I'm thinking high voltage lines, your HTM MV lines for the municipalities, ESCOM. You also have the road infrastructure where your protection barriers are always stolen your infrastructure, civil infrastructure. So I'm just thinking out loud here with regards any built environment as to what's the limitation of your solution. Sorry, I just these three questions, and I will also add, I think there's one question also from the audience, but maybe for now, these few questions. Thank you.
Okay, is that better? Can you hear me now?
Yes, I can.
Okay, thank you. Thanks, Shepard. So from an AI point of view, so I suppose in the security industry, there's a saying that I've learned from a colonel, I think, in the police force. Crime takes place when there are two things present at the same place. It's desire and opportunity. We cannot take away the desire. So the solution will apply to almost varied applications. At the moment, we're looking at rail infrastructure. You cannot take away, there's always the risk that is vandalizing and theft of assets, high value assets. So what you are trying to do with the technology is to limit the opportunity. We've seen now, numerous occasions over the last year, when you engage and you actually speak directly to the person who's a would-be thief, but they're on the premises, you've identified them, it is already a deterrent, because now they know that the armed response team is going to be looking out for somebody wearing red pants and a checkered red top. So they would rather walk away. When we were doing the installation, some individuals would actually threaten us to say they're going to steal the equipment you're installing. Well, we've just recorded everything that they've said, shared that with the field team, and the AI portion and taking that information further. So now you've got the person, what are you going to do with it? So firstly, any incident is recorded. There's a video clip and a picture of the person who is now attempting to vandalize or steal equipment. So we've got a visual immediately. So we've got hard evidence of this individual. When from an AI point of view, how are we trying to use AI? We can't stop the theft, but each time there's an incident, so what we found now, the theft is not so, in this past year, they've not hit any of the substations that we've protected. So now the railway network, as I said, it's almost a 500-kilometer railway network has been hit. So they've been stealing the cables, probably slightly out of the towns. It's a rural area, but what we found is the task team that's working with Transnet, so it's released all the property owners and Transnet, they've actually identified that each area which is hit gets highlighted on Google Earth. We actually track to see what are the escape routes. So before, all the effort would be to go run to the point that was hit on the railway line. So it's Worcester Station, 40 kilometers north, and everybody rushes there. Now the intelligence has told us, hold on, if you hit that thing there, there's only a road that comes into the town, and they know exactly what the road gets you back into town. So the AI that we're using more and more is to get information as to where are they going to go to if they hit us. The AI discussion goes further, where we're trying to get Internet of Things devices. So on that railway track, if I look at the granite stones that's sitting underneath the railway line there, so we are looking at cameras or sensors. It looks like rocks. So the next phase of the next bit of concept that we would want to put in the field is it's cameras and sensors, Wi-Fi devices that's just lying like your aggregate, if that's the word I think the engineers use or the railway guys use. It's the aggregate. It looks like a rock that's just lying there. So you're wanting to get good information so we know how we can pinpoint. So it's obviously it's not an exact science. You try and stay ahead of the criminals, but that's how we are using AI at the moment. In terms of the platform, Shepherd, we've standardized on the Hikvision platform. We think it's very robust from an alarm platform. We've looked at various ones. So Ajax is a different unit, but we try to go with one service provider. It's all IP based, so it's all cloud based. So it's easily pushed to a cell phone, and you can view the footage. So if you've got access, if you need to disable an alarm, the supervisors can go in and very easily manage the situation and see the footage themselves. Obviously, with a bit of a rider or waiver, we only allow people who are audited on the system. So even if access is given to an individual, everything that person is doing is being recorded. So we do not leave it to chance that it's inside information. People know that the substation is offline and therefore it gets hit. So we kind of do the self-correcting, self-checking and policing. The platform, it's highly resilient, multiple drives, it's on multiple locations. So all the information is in 3 locations. So can you get away with any incident is triggered and recorded in 3 different locations. So that's the platform. I don't believe there's a good interoperability between any of the service providers. We can within the Hikvision take over different systems. Vigilon, I think, is was a market leader. We can take on most third-party providers. The camera feed is not so much the issue. You can put any camera in the system, Shepard. It's the NVR has got the technology in it. So the camera, most of the technology is on a camera these days, so you don't have to trigger an event. The camera's got the intelligence, it triggers an event. So if a human crosses a line, it will be triggered automatically. The last question, any other high-value assets? Absolutely. More and more we're having to disguise and protect the technology first. So that's the first thing. You can't just put in a camera. All the cameras face each other. You've got sensors, everything protecting the cameras and the sensors. So it's a multiple layered approach, Shepard.
Thank you. Thanks, Nathan. I've got 4 questions. I think the first one is from Philip Nicholson. He wants to know, will pole-mounted cameras powered by a solar panel work in remote areas? He mentioned that Sanral appears to use them successfully on some Eastern Cape Road. Maybe it's this question. And there's another one from Nolufefe Ngalonkulu. So Nolufefe is saying, does your system use the 2G network provided by Metro Rail, or is it it uses the public 3 or 4G network to interconnect the 3 control rooms that you've mentioned? Also from Nolufefe, also how much bandwidth is required specified on the transport network to connect to your control room? And maybe a third one also from Nolufefe. Okay, he was, I think, sorry, I'm not sure if it's a he or she, apologies for that. Thank you for your presentation. What is the overall plan for rolling out this security equipment throughout the country? To what extent is it readily implemented, and who's the owner of the assets, and how will you operate it on an ongoing basis? Maybe let's stop here. I don't know if that's we can always go back to some of the questions, Nathan, if you want me to do so. Thanks.
Okay, I'm going to come back to the last one, Shepard, just for you to repeat. But okay, the pole, can we use this with a pole and solar? Absolutely. So the challenge is really, if you're putting a pole, so if most of the farms, I was out in the Northern Cape, Kakakama and Kalahari area, Sutherland and Springbok. So you've got huge areas that you have. And so if you want to protect the farmers are doing that to protect the perimeter, because you want to get the perimeter protected as your first line of defense. So if anybody crosses your perimeter, you're notified, and you can then start to react and respond to the situation. Would be theft, or just call it an incident for now. So for having a pole and a solar panel, so you need a solar panel, a battery, and a camera, but then you also need communication. You need to have that camera. If something happens to the camera without comms, it cannot send an alert. So typically you'd have the camera, you've got the solar panel on the top to give solar charging of a solar inverter, which has a battery in it. So you need those things there. Then you need a Wi-Fi device to link to another camera pole. So if you've got open space, no trees, nothing in the way, you are looking at some of the devices. You can have Wi-Fi that runs close to from 500 meters to 1,000 meters. So all you need to do is you need to have, because the poles, and they typically look back on each other. So if you've got a square perimeter, you've got 9 poles. I'm just thinking using a number facing in one direction. You want to have one last camera facing back, so every camera's got eyes on it. Because what they typically do, you want to go with a steel pole. You want to have some stays on it, because if they try and take a chain wrap it around the thing, and they'll drive it off or knock it off. So you need those physically to protect the device, but we see that more and more often. So as long as you've got, I think the monitoring is key. You can, and I was out in Calitzdorp recently, in the middle of nowhere, Sewe, you've got the spell, you've got a speaker right there, and about 4 or 5 cameras. As soon as they know that they are being watched, and they are being watched real time because somebody has just spoken to them on the device. I think that goes a long way. So yes, absolutely, the poles and solar is definitely an option. 2G metro rail question. Currently, this is running on 4G and 5G. It's all private, so it's not running on the metro rail network. The contract that this is part of is, some of you may have heard, it's an outcomes-based security model. Previously, Transnet would be contracting service providers to provide security services. Every year the bill gets bigger, but there's no stopping of the theft. This model, so Sinkobeli is actually the contractor that has that contract. They are providing security, but there's a catch and there's a penalty. If they are hit, if the substation, the line is hit, the security company, there are penalty clauses. So it's in the security company and the security ecosystem that is part of Sinkobeli's mandate, of which I am a part, is to make sure that there is no compromising on the network. So currently it's not using 2G, it's running on 3G, 4G, and 5G where we've got that capability. I think it's only in the CBD in Paarl and Worcester where we've got 5G, because as I mentioned earlier, that is mostly all rural. In terms of bandwidth requirement, these are 4K full HDMI cameras. There are typically 10 cameras per site. So a 40 megabits per second line would be ideal if all 10 cameras are recording. But remember, we are only recording when there is human movement and or a vehicle present on the site. So most of the lines are running on about 20 megabits per second. The LTE connections, the 3 and 4G lines are about 20 meg, and that suffices. When you trigger the alarm system, it actually just sends a 10-second clip, but it sends the picture, the footage of what the sensor picked up. So once again, it's a much smaller picture, it's not full video. So that talks to that question. What is the possibility of rolling this out to the rest of South Africa? I think this is the first time that an outcomes-based security model is being looked at. I think the new board of Transnet has said we need to change it. Leaving things, doing the same thing each and every time, putting more people. The criminals just work out, okay, the vehicles are all in Paarl, therefore we hit something outside of Paarl. They then work out a pattern. So you need, at the moment, the technology is autonomous, it's automatic. The devices trigger. You don't need a human to trigger anything. There's no panic button. The system does all of that. And so it can roll out. I think we've just proven, I think this is the first time that the Transnet have seen that they've got access to this capability. It's not sitting on their network. Once it becomes part of, let's say, Transnet's network, the whole, I suppose it comes down to data governance and to put in this network, to join it to the network. I think it'll take years just to clear the, let's just call it the protocols, but at the moment it's still completely independent, Shepherd. I couldn't get the last question, it was too much. If you can, was that the last question? I think it was, yes, that was the last question, Shepherd, so yeah. I think that answers that one.
So the second, yes, I think the second last question was about the implementation and I think ownership.
Okay. Yes.
Yeah. I think it was the overall plan. It was who's the owner of the asset and who will operate it on an ongoing basis. So that was the last. That was the question. The last question from the previous one. So the very last one coming from. Also, we've got two. Sorry. All right, the last two. So the first one that I'm reading for you now, it's coming from Quentin Lowe. So Quentin wants to know, how do you manage the risk of antenna integrity? It seems all antennas are external and prone to be vandalized, even with visual verification. If your response is slow, which is usually the case, the whole solution is compromised. So that's the second last question from Quentin. And from Janet. She wants to know, is there any reason you don't use power line communication as a backup or alternative to cellular network?
Okay, thanks, Shepherd. So just in terms
so
of—
these are the last two questions. Thanks, thank you, Nathan.
Thank you. So to speak to the last question in terms of who owns the infrastructure. So in the model that I've just shared with you, so Transnet owns those assets. It's Transnet assets. The contract for the security provision of security and electronic surveillance deterrent. It's a solution to deter would be vandalizing and theft of the asset. So that is all outsourced and all belongs to Sinkubile. The entire network of support companies, myself as an installer, Ditabo, who manages the control rooms, and so we support the ecosystem. So within Transnet's operations, the one control room, the last one I shared with you, is within Transnet. So the aim is, I think, well, I can't speak to what happens after the contract, but the thinking at the moment is that Transnet then operationalize and bring this in-house. So currently in the Transnet control room, we have Sinkubile staff who are operating and managing the control rooms, because as I say, it's a vested interest. If the asset is compromised, Sinkubile will lose money on the contract, and therefore it's in our interest to have people there. So that speaks to that question, Shepherd. So that's the model with which the solution has been rolled out. So I'm just showing you the technology which is there. I don't wish to comment on the contract issues. In terms of Quentin's question, are the antenna vandalized? I think at the moment in South Africa, solar panels are probably one of the hottest things that they are looking to steal. So strangely enough, not one incident of attempted theft of the antenna, the dishes for which we are using. People will try and steal the copper, and they will try and steal the solar panels because there's a ready market for that. So we've not had any vandalizing of it. As I said, some of the pictures are shared with you. Absolutely no fence. And you've got, I forget the, I think it was at Babian, you got the railway line that goes past this thing within less than 5 meters. And on the other side, there is no fence, so people just walk through the substation. So they see it, but because there's a response time, so the armed response, so Sinkubele's, the way they've tackled the mandate is they go through to all the communities, they share with them, guys, we are monitoring this substation. We will pursue and get you once we have got you on footage. So there's a bit of reaching out to the community, but once there's a trip, because I think what the thieves would do, they would break something and wait to see how long what the response is. Then they know for the next time that is the response. But because we've got footage and you've just spoken to them, we know exactly who it was that we've got there. These cameras, you'll be able to do facial recognition very quickly to say this is the same person who's been to the site. So it's typically criminals who've targeted the site. The AI which we've used, we've actually picked up. They used to use bakkies, now they use high-speed hatchback cars, and they would be on the lookout for hatchback cars which are sitting low on the road. So there are a few arrests were made in Kraaifontein in the Western Cape. So I suppose it's having the police system, and there's a task team linked to Transnet. So there's been a few deaths and shootings where perpetrators have opened fire on the armed response team, they've retaliated. There's an immediate task team that's escalated. So within 24 hours, that would get the task team out there. And I don't know, I don't have it on, I can share it, but recently 2 jail sentences in the Eastern Cape, 20 and 30 years. So what actually happens in the Saldanha line, the train stops to get the iron ore into Saldanha Bay. The sidings is about 1.9 kilometers of train that you got standing while it waits for the next one to come out. They broke into the train, they steal the batteries on the train. The asset value that they stole on the train was 57,000, but they compromised the network. They needed to get another engine to pull that thing out of the way after they damaged the train. 20 and 30 years is the return. That was, I think, last week in last week's news. Just to go to the power line backup, the last question. Yes, we would like to be on a fiber network. So within the Transnet network, we are exploring that. But once again, we do not want to have this network, this system solution open to an environment that we are not controlling. As soon as you share this, you've got more people who have access to a system, and therein lies the problem. As I said right up front, we self-police our own people. We make sure we monitor and manage that no one within our trusted network is doing anything which is not supposed to be done. So as soon as you open that gate, and now you've got all and sundry getting to it, ideally we can secure it with VPN access. But I think once you hand over that, or the next steps, I think the jury's still out on it as to how we do that. So I don't know who posed the last question, Shepard, but that's my thoughts on linking to fiber would be better. It would be quicker. Everything is linked to a cost. So we're moving that way already. But it's a case of getting the segregation, the lines, making sure there's compliance, because you are now introducing a third-party network to a state-run entity, and you cannot compromise the integrity of either network. So I think it can be done. It's where whatever makes financial sense, whatever the contract stipulates, I think is where it's at the moment. Thanks, Shepard.
No, thank you, Nathan. Yeah, I know there's yes, there's also a few innovative that use the rail power line as means of communication, and I agree with you. It can be done, and to what cost, and maybe what does it mean to security compromise? Yes. I think that's part of the innovation that one will have to consider.
Just a quick thought, Shepard. I mean, in terms of the actual line itself. So, yes, currently on any fiber line, you've got the technology to determine at which point the line is broken. So you've got a 2,000 meter line length of cable. You can actually run a probe and you can pick up that it's broken at 1,500 meters from end A. But to have something to do that while it's running and now somebody cuts it. So I think the technology is going to improve. There's advances in that direction. So when you cut the line, that the system needs to know, oh, it's broken there. So those are the advances that you hope to use down the line.
Thank you so much. Thank you once again, Nathan, for such a detailed presentation, and also sharing some of the live projects. I know during COVID we've experienced quite a lot of infrastructure damage, and this is a solution that I'm sure most engineers are looking forward to, and your information will be obviously shared for those that still are having few questions. They can touch base with your office as well. Mings, I think this was the last question, and I see there's a hand from Nolu Fefa. I hope the response that we've given to Nolu Fefa covered her question there. But I think that's this was the last question, Mings, from our end. And thank you so much. I would like to hand back to you.
Thank you very much, Shepard. Thank you very much for standing in for Crystal, the chairperson of the KZN Centre, for us tonight. And Nathan, thank you very much for your time. It's a very informative presentation. Ladies and gentlemen, I just want to make you aware of the handout section. You will find the What Now August issue in PDF format, if you're welcome to download that quickly. and the SAIE Training Academy brochure if you need to earn some CPD points. And if you need to request the presentation from Nathan, I'm going to put in my email address in the chat box at the moment. You're welcome to send me an email to request the PDF presentation from Nathan. Ladies and gentlemen, herewith we end the KZN Centre webinar. I thank you very much for your attendance and have a good evening. Goodbye.